Okay, so rational functions and wholes. We've already worked with rational functions. We've been able to solve them. We've added and subtracted and multiply and divide, blah, blah, blah. So now we're going to get this unit's about graphing them because this is very important for calculus. There's times in calculus you need to graph them. So yeah, there's this scary clown. So just remember, a rational expression is a fraction of two polynomial expressions. And a polynomial is like the x squared plus 3x plus whatever. You can't have negatives in your exponents and you can't have fractions. Okay? So when you're doing this, remember first you factor everything and then simplify monomials, that's such a hard word, using exponent rules, and then eliminate common binomial factors. So let's just simplify some of these. So if we have y plus 8 over y squared plus 2y minus 48, you can factor the bottom there to y plus 8 and y minus 6. Well, since we have a y plus 8 on top and bottom, they cancel, and I'm left with 1 over y minus 6. Okay, yeah, let's get that clown off there. This one, so first we're going to pull out a GCF. So like on top I can pull out a 2. And I'm left with r squared minus r minus 20. On bottom, I can pull out an 8, and I'm left with r plus 4. Then I can factor the top to be r minus 5 and r plus 4. And then the 2 and 8, 2 over 8 simplifies to 1/4, so that can just become a 4 on the bottom. And then the r plus 4s cancel, so I'm left with r minus 5 over 4. I'm hoping all of this is revealed. Okay? This one. Now first, we need to put it in standard form. See how the bottom is 7 minus p? Standard form, we need that to be negative p plus 7. We want the exponents to go from greatest to least, so let's just rewrite that. And then I'm going to pull out a negative on the bottom, so that becomes p minus 7. And then p squared minus 49 factors to p minus 7 and p plus 7. So those p minus 7s cancel, and I'm left with p plus 7 over negative 1, which you can write that as negative times p plus 7, or you could even go a step further and write it as negative p minus 7. Okay, any of that last line is acceptable. Okay, now this one, so factor GCF out first. So I'm going to factor out a 3a on top, and I'm going to factor out a 6a squared on bottom. Now on top, we have that 4a squared minus 1. Well, we're just going to square root both of that. That's the difference of squares. So that's going to be 2a minus 1 and 2a plus 1. And then the 3a and the 6a squared, 3a divided by 6a squared, we're left with 1 over 2a. So that 2a's on the bottom. And then those 2a's plus 1's cancel. So I'm left with 2a minus 1 over 2a. And remember, those 2a's cannot cancel. Don't make that mistake. Okay? And it's the same reason, like, let's say you had 2/3. Okay? We could rewrite that as 1 plus 1 over 2 plus 1. Right? Now, I could cancel these 1's, and then I'm left with 1/2. But 1/3 does not equal 1/2, which is the same exact reason we can't cancel those 2a's right there. Okay? So then that's our answer. Okay, now let's get into wholes. So we're going to build up to this, and we're not going to actually graph this until the last day, but it is possible to have a graph where there is a hole. So basically, say you had like some graph here. What that's saying is if we're going along this graph, there would be a hole right here, and then it would just like keep going. Okay. And that's on a quadratic. You don't have holes on quadratics. That was a bad example. So if you had something that looked like this, I guess it doesn't have to be a quadratic, but like this, and then like this side goes like this. Okay, that's a hole, meaning like it approaches that point from both sides, but there is no point right there. Okay. Before putting the rational function into lowest terms, factor the numerator and the denominator. Okay, because the way we get holes, it's the things that cancel. So if there's the same factor on top and bottom, there's a whole because those cancel. So we set that factor equal to 0 and solve it. This solution will give us the x value. And then we simplify the rational function. And then we plug that x value into the simplified version. And then that will give us the y value. Okay, that's a lot of words. Let's do it. So let's factor this top and bottom. So we get r plus 7, r minus 3 over r plus 7, r minus 6. Those r plus 7s cancel. And that's where our whole is going to be. So I'm going to set the r plus 7 equal to 0, which means r equals negative 7. And that is the x value. So our x value of our whole is negative 7. Okay, and then we can actually cancel those. And I'm left with r minus 3 over r minus 6. And then I'm going to plug that negative 7 in for the r. So I get negative 7 minus 3 over negative 7 minus 6, which is negative 10 over negative 13. Negatives cancel, so I'm left with 10/13. So for this function, if we were graphing it, there would be a whole at negative 7 and 10/13. Okay, let's do this one. So again, factor top and bottom. So we have 8 and then a squared plus 6a plus 5. And then 4a times a squared plus 3a minus 10. Keep factoring. So that top factors to a plus 5 and a plus 1. The bottom factors to a plus 5 and a minus 2. So we have that a plus 5. That's what I'm going to set equal to 0. And then solve it. So a equals negative 5. So that is our x value. Whatever one you solve for first is your x value. Now we need to simplify this, which can simplify down to 8 over a plus 1 over 4a, a minus 2, which the 8 and the 4 can simplify to be 2. So that's 2 times a plus 1 over a times a minus 2. Now here, I'm going to plug in negative 5. So we have 2 times negative 5 plus 1, and then negative 5 times negative 5 minus 2. So that's 2 times negative 4, and then negative 5 times negative 7, which is negative 8 over 35, which is, can't reduce, it's negative 8/35. So we have a whole at negative 5, negative 8 over 35. Okay. Let's do this one. Again, let's factor it. So I can factor out a 7x squared on top. I'm left with x squared plus 4x minus 5. On the bottom, 5x squared plus 18x minus 35. Now, to factor the bottom, you either have to use slip and slide or grouping, but it does end up factoring to, well, the top is x plus 5x minus 1. The bottom is x plus 5 and 5x minus 7. So we have this 5, or x plus 5. Now I'm going to set x plus 5 equal to 0, so x equals negative 5. And then simplify this. Those cancel, and we're left with 7x, x minus 1, and 5x minus 7. And we're going to plug negative 5 in for the x's. Okay, so on top, we're left with 7 times 25 times negative 6. On bottom, that's negative 25 minus 7, which we get negative 1050 over negative 32, which reduces to 525 over 16. And you could just put that whole thing in your calculator and it will spit out that number for you. So that is, we have a whole at negative 5 and 525/16. Okay. Let's do another. So negative 7a squared plus 25a minus 12 over 2a squared plus 2a minus 24. So I'm going to take out a negative on top, take out a 2 on bottom. If you factor the top, you end up getting 7a minus 4 and a minus 3. Factor the bottom, you get a plus 4 and a minus 3. Those a minus 3's, that's where our whole is. So we have a minus 3 equals 0, which means a equals 3. Which means our x value there is 3. Now we can take that, those cancel, plug it back into our simplified version. So we have negative 7 times 3 minus 4 times 2 times 3 plus 4. So that's negative 21 minus 4 over 2 times 7, which is negative 17 over 14, which doesn't reduce, it's 17/14. So again, or not again, but we have a hole at 3 and negative 17/14. Okay, we're going to get into graphing this and finding asymptotes next time, and then we'll piece it all together and actually I'll show you how to actually make a graph. This is kind of funny. Okay, anyways, hope you guys are having a good day. Bye.